It's like living in the Twin Cities and you do not know. Here's coffee. I told you coffee is going to be here. Did you buy it? You have to buy it? How much are they?
Like $2.
$2? Okay. Thank you. So, I'll get coffee guys tomorrow too. We're running out of coffee, so I'll grab coffee. Chapter 4, branch circuits. By now, guys, you know what we have talked about. This focus on the branch circuits. But, so my friend, we have three very important circuits in the power system. Any power system. Anybody can repeat them. What are they? The three very important circuits. Feeder is one of them. Yep, start from the beginning. Service, feeder. If you know it in this order, guys, you would never go dull again. You would never go straight. Because people mix them up all the time. There are three articles that talk about them. These three different circuits, they are unique and separate, and they have their own unique circumstances. So I can use them in terms of wiring methods. I can use this MC cable to be, look how, this MC cable, not the size, but the type MC cable, I can use it to be a service conductor, service circuit, or a feeder circuit, or a branch circuit. Does that make sense? Now, there are certain circuits are not allowed to be services. This one, guys, this cable is not allowed to be a service circuit, a NAM cable. How would you know if they're allowed to be used as a service or not? When you go to the article in the NDC code book, if you're in doubt, you go to the article, use is permitted. There is a section that says use permitted, use not permitted. It will tell you where you can use it. You can use it as a branch circuit, feeder, and service. Yup. You can use it as a branch circuit and feeder only. Then you can't use it as service. Very, very easy, guys. And you will get to know them more as you go. Okay, number of branch circuits for set of loads. So this is against commercial. So we'll talk about the number of branch circuits for a bunch of loads. How do you decide the number? Correcting factor for branch circuits. When it comes to branch circuits, guys, we always bundle. Because it's cheaper, I told you about that one. It's cheaper to put multiple circuits in one pipe like this, 3/4 of an inch. When we bundle them, you end up with more than 3 HOTs in one pipe or one cable. You can have a cable also with more than 3 HOTs. Then you end up with derating. Why would you derate? Because the more conductors carry current, the more they create heat. When they create heat, they heat each other's. And heat, as remember what Chad's going to say, heat is enemy number one of electricity. If you can get rid of heat, you can make a conductor, number 14 conductor, guys, that's rated for 15 amps, you can make it carry 100 amps. If you can cool it fast enough. Heat is enemy number one. So when you have multiple conductors enclosed in an enclosure like this, you can imagine the trap of the heat. You're cooking them, basically. So that's why they want you to do it. Okay, we'll talk about this one, and we talked about this one in the past, guys. Continuous load. We talked about continuous load. Anybody says what continuous load? How many hours? Thank you. And what do you do with the load if it's continuous? 1.25. You up it 25% for safety. So if the load is 10 amps, you put 25% on it, it becomes 12.5 amps, and you size the conductor. Why? Safety. Motors are also, can you guys write yourself a note? Motors are always considered continuous loads. Always. Heating loads are always considered continuous loads, right? Think about it. There is a pump. Don't you think the pump will run more than 3 hours? So you have a heater, right? Baseboard heater. Any type of heater. Do you think the heater could run for 3 hours or more? So these are heaters and heating loads, and motors are always continuous load. Determining the correct ratings, the rating of the branch circuit. Anybody can tell me this? What is the rating of the branch circuit? How do you determine? You got it, huh? You made it with that pink sky. What determines the rating of the branch circuit? Thank you. The circuit breaker ahead of it. Now the conductor size. What determines the rating of the, when you say this circuit, this branch circuit is 50 amp branch circuit? The overcompression device. Thank you. You guys were paying attention. I thought you were not. What's going on here? You surprised me. See, you talk about if you didn't find the answer. These are the answers. That's the most important thing. I mean, the details is, it comes. Determine preferred type of wires for the branch circuit. Can anybody tell me if if you see one installation, you'll be right 90% of the time. Okay. Anybody can give me the installation? Start with T. T, edge, N. So N is 90%. If you will be 100%, what would you do? Slash T, edge, W. If now you're 100, if somebody tells you guys the same installation will have two ratings. If they tell you what the installation do I need for this circuit, if you say THH, you're right 90% of the time. If you say THH/THW, you're right how many? Almost 100% of the time. There's other installation used for special application, but mostly. So the wire for a branch circuit. Okay, the type of conductor preferred is what? Copper or aluminum? Copper, CU, we love the copper. Okay, minimum size conductor for branch circuit. Determine the minimum size conductor for branch circuit. We'll talk about these one. You always size the branch circuit, guys, and the conductor and overcurrent protection device based on what? The load. Always the load. Give me the load, I get your branch circuit. So that's and we talked about. Let me go over that one. Residential 15 amp circuit. What do you guys use 15 amp circuits for in dwellings? General. Yep. Receptacles and light. 20 amp circuits. Bathrooms, kitchens, laundry. These are dedicated circuits. Now let's switch to commercial, because we're commercial now. Commercial, do you use 15 amp circuits? Can you by code? Yes. Should you? No. No 15 amp. Drop the 15 amp. Can you use number 14 in a commercial? Or should you use number 14 in commercial? No. 12 is your minimum. Okay, 12 amp circuit. When you have a 20 amp circuit, so here's my circuit. Now, right in here, what type of load you put here? The most notorious and famous is what? Lighting. So you put your lighting load, right? We always separate light and receptacle in commercial, always. Unlike in residential, we can mix them. And by the way, in our project residential, I'm telling you guys to split them too. So the rule is split residential light and receptacle. You don't put them in the same circuit. Anybody wonder why? If you're short, most likely you will show. How many of us go up there and go monkey around with the ballast every day? But a lot of us plug in. You guys came and plugged in your computers in these power strips and so forth. So you could monkey here around and trip the circuit. If you trip the circuit, you can turn the light off, and that could be safety hazard. Okay. So the second 20 amp circuit that you can use always is what? Receptacle. Thank you. Are you gonna make it? That's right. Receptacles. So between these two circuits, guys, you have just covered. Between those two circuits, you guys literally you just covered 70% of the branch circuit. Lights and receptacles. Okay, let's go to the other 30%. What are the other 30%? Can anybody just guess? Mechanical equipment. Thank you. All the mechanical equipment. Okay, the other 30% and mechanical equipment. Now, what size circuit do I need for the mechanical equipment? The mechanical equipment. Well, now these vary. These guys vary. They can be 20 depending on the size. That's what we're going to go over. They can be 30. They can be 40. They can be 200. They can be 1,000. Can you see that? A rooftop unit, 1,000 amp. So the mechanic depends upon the size of the mechanical equipment, and we'll go over how to size it. That's it. That's all your branch circuiting in a nutshell, basically. Does that make sense? Always remember the 20 amp circuit for lights and receptacle, guys. Mechanical equipment, it depends upon the equipment that you're feeding, and I'll show you how we size it when we talk about motors. But typically, guys, a lot of them are in the 30, 40, 50, 90 amp branch circuit. Okay, and of course, with this one, what size conductor do we use? 12 and 12, and with these, well, it depends upon the amps. Okay, so that's it. That's your branch circuits in a nutshell. Yes, sir.
After yesterday's class, I went home and looked at my computer. It was wired wrong.
What was the wire?
The guy had taken, see, it was orange. Because I was like, oh, wait a minute, is it orange or not? So I looked, it is orange. So this is 12, right?
No.
Or 10.
This is 12. This is 10. If it's orange,
It was orange, it was 10.
this one 10. Yeah.
Yeah, but it was a 2-wire.
Yes.
It wasn't like 3-wire like that, where you see.
Well, the AC does not need a neutral. AC
Right, it's not, it doesn't have the.
ground.
It was white and black and green.
Oh, the green is the ground. That's okay.
Is it okay like
Yeah.
that?
Yeah, you need two hots for the AC.
But they made the white one, they colored it red.
Yes, that's okay. That's cool. Re-identifying the white as a black in a cable because cables don't always come. If you have 210, this is 310. So I have three colors. 210. If you have 210, they always come black and white. Now, if you want to use this as a hot, the code allow you to do that as long as you identify with a little tape, and make it black.
Right.
No, they did it right. You don't have to sweat it too hard. And they gave you even a fully insulated ground, which is above and beyond what the code asks for. So you're good. but here's my but here's my story. Since you're talking about this one, this weekend I did electrical work for my wife's cousin.
Make the white identify red.
Yes.
Yeah, they got
Yes.
white, red, or black.
Yes. Typically black, or if you can identify as red too. If you're using the white conductor, guys, other than the grounded conductor, if you're using the white conductor, other than other than grounded conductor, which is neutral, you must identify it, and there are rules for using it. The only time you are allowed to identify a white as a black, the only time, if they're in a cable. If they're in a conduit, what do? Pull another color, any color you want. But when you're in a cable, you have no choice of pulling another black in this cable, if it's two. So they allow you, for ease of installation, to re-identify the white as a black.
That was gonna do that. If it was wrong,
Yeah.
I was just gonna run another.
You're a good man. But here's my story. I'm going to tell you. I was doing electrical work on Saturday for my wife's cousin, uncle actually. And long story short, there's a pipe going to his air conditioning. And I don't know if you guys have seen in the air conditioning, they have a whip that goes to the air conditioning, and they come with a box that has a receptacle in it. They use it a lot for commercial. A receptacle. The disconnect have a receptacle in it, which is beautiful. Used commercially all the time. You need a receptacle within 25 feet of mechanical equipment to maintain them. That's code requirement. You guys are going to do that. Wherever there's a mechanical equipment, you are to provide a 15 and 20 amp receptacle, 120, right within 25 feet of the mechanical equipment. You probably have a receptacle in the backyard that's within 25 feet. You can service it. So anyway, so in the same box, so the owner wants to have another receptacle 12 feet away. So I looked, and the pipe is coming, half-an-inch pipe is coming all the way here to the air conditioning. I said, okay, I can cut that pipe and put a box, regular box, and then use the circuit that's feeding the receptacle here, which is a separate circuit, not the circuit that's feeding the air conditioning, complete separate circuit. And he's happy now. He has two receptacles. He has a pump if you want to put it in that area. Anyway, so easier said than done when you start cutting with existence. So I did the whole thing, but when I pulled the wires out to cut the pipe, it was wired with number 12. So the electrician brought number 12 inside the pipe into the box. In the box, the fixture, the whip that comes from the air conditioning has number 10. So he brought the number 10 wire very clearly. You need number 10. He to the box. I don't know if you ever wired them. There's a couple of terminals there. So he brought 10 and hot 10 and 12 and tied them together, which is fine. And then I went to the panel, and he put a 20 amp circuit breaker, which we typically do what? With 30 amp circuit breakers. And the air conditioner is working. So in a sense, it's not violation of the code. It's not violation of the code. It's violation of the conductor, because here's what he did. He did 20 amp circuit here, two conductors number 12 into the box. Now inside the box, the fixture web that goes to the AC, that was two number 10. And this is your AC, and this is your disconnect, right? So 10, 12, remember, what controls the circuit is what? The overconduction device. As long as the overconduction device is rated to protect the smallest of the two, you're good to go. That's not violation. But what the violation is, the equipment here, if you read on the nameplate, it says an overcurrent protection device 30 amps. But if you read it clearly, it says maximum. It says maximum. So can you go lower than 30 amps? Yes. So technically, he really did not violate anything other than the normal wiring methods, which we typically throw a 30 amps on it. So no violation of the code because this says max. If you go ahead and put 5 amps if you want. It's not going to work, but it's safe. It'll trip all the time. So anyway, so that was I thought that was an interesting.
So, like in mine though, that whip, it's going in there, the red, black, and green.
Yes,
So the green
the green is the ground,
ground, but there's no
red, black. Yep,
black, black.
yep, and the red will go to the re-identified black, the re-identified white,
Yeah.
and black goes to the black, and you're good to go.
What about like quick ground?
The green goes to the green.
Yeah.
Inside the box, are you wired with cables? So they tie the ground to the ground
Yeah. And it,
inside the
I'm
box.
just saying, like, shouldn't it be shouldn't it be a 10-3?
No, no. 10.3 we use it for and how would I know? Here's a question. How would you know? You're really based on the equipment. I told you guys neutral. When it comes to neutral, if the equipment runs in 240, the first question, Gary, they're gonna ask if you don't know is, do I need a neutral if the equipment runs for 240? Now, air conditioning, because it's commonly appliances, we use them all the time. Outside unit, they do not need an air conditioner, a neutral. The manufacturer make the compressor and the blower, the outside blower, run at 240. And there's a little control relays there. And I don't think they even have a transformer. Everything is running at 240. That's it. They don't need 120. Now, if you go to the electrical dryer, the manufacturer of the electrical dryers, yes. Now, had they could have made the heating element, the one that heats, 240 in the dryer, electrical dryer. That's 240. Now the motor that rotates the clothes as they move around, they make them run at 120. Now, they could have made them run at 240, and then you need two wires. But I'm sure they have their own reasons. Every appliance is made differently. So they think it's the best way to do it is to run one at 120 and the other at 240. Now, you as an electrician, electrical designer, now you need to know that. If you don't know, you need to ask and then provide the neutral or not. Same thing for three-phase equipment, guys. You're going to see an air handling unit. On an air handling unit, you're going to see it's need three-phase 480. Okay, do I need neutral? No, you don't need a neutral. Almost all three-phase equipment does not need neutral. Okay, so that's basically what the neutral and what's not. Okay, now you guys got us into a whole different tangent here. Installing cover type conductors and sizes, guys. Minimize set forth by the NEC code book. Long, uninterrupted life. Big deal with ambiguity. So we'll talk about the ambiguity, guys. I always tell the people when you find the ambiguity of the conductor, take three things into consideration when you size the ambiguity. You will never go wrong, Brandon. If you take three things into consideration, write them down from your friend chat. Okay, the first thing you need to size for, guys, the first thing is the load. Load. The load like in amp. The conductor. Amp like in 50 amps. Okay, that's the first thing you need to take into consideration, the actual load.
What is this for?
This is sizing the ambiguity conductor. Ambiguity conductor, you have to take the load into consideration. Then underneath it, ask yourself, is it continuous or none? Non-continuous. That's the first thing. What do you do with the continuous, gentlemen?
1.25.
What do you do with the non-continuous? Leave it alone. That makes sense? First start with the load. Is it continuous? Up to 25%. Is it non-continuous? Leave it alone. And size your conductor. Number two, when you size your conductor, derating. You need to take into derating. How do we derate? Number one, there's something called derating based on temperature. Temp, temperature derating, and bundling. Bundling. What's bundling? Putting more than 3 chemical conductors in a conduit. You have to derate. And the last one that people forget all the time about, guys, derating based on temperature, temp, and bundling. Did I spell it right? Bundling. Bundling. Okay? The last thing that a lot of people forget, guys, I want you to put it in your mind all the time. Voltage drop. Voltage drop. Voltage drop. So you have to take into consideration voltage drop. That's why when you size your feeders, if you're right on the border, you can go up or down, go up. Why? Voltage drop. Always take this in voltage drop. You don't go, even if you can, if your conductor is close to, I can get away with 3/0, but I'm really right on the money for 3/0. Maybe it's a good idea to go to 4/0. Okay? So these are the three things that are going to take into consideration when you size the conductor. Got it, guys? So if you did your sizes, I always tell the people, if you did the size based on continuous, non-continuous, and you came up with 1/0. If you did your size based on derating and you came up with 2/0. And if you did your size based on temperature and you came up with 3/0. Gentlemen, which circuit, which conductor would you use? 3/0. 3/0. Now, a smart engineer and a designer would not group more than 6 circuits in a pipe, so the rating become not a big deal. You don't worry about the rating if it's up to 6 circuits based on the rating factor. And if you're going in outside in a temperature, don't bundle because outside becomes higher temperature, especially in the southern states. Then you don't have to worry about step number 2, right? Now step number 1, oh, no problem, continuous, non-continuous, and voltage drop, and worry about voltage drop. So if you're on the border, always go up because of voltage drop. That's to summarize the whole system, gentlemen.
You said it's no more than 3% voltage drop.
Yes, 3 on what? Feeders, 2 on grind circuits. Why 3 on feeders? They're longer. Feeders tend to be longer. Insulation appropriate. Now, when you size a conductor, we talked about this one, guys, before. The first thing you need to choose is the insulation. T, H, H, N, or T, H, W. The material, the resistance of the material, Cu, copper, and of course the resistance of the cable will depend on the size, the material, and the length. That's why we always use copper, because then I have no control over the length. Typically, if the owner wants you to put a lighting fixture right there, can you go say, no, you don't want a rock, don't put it right there? I mean, can you? If the owner wants to put a lighting fixture there. We guys, we are servants of the owner. We work for the owner. We want him happy. So I have no control over the length. The length, drop it. I have no control over that guy. Do I have control over material? Yes. I can decide cover. Here's my cover. Do I have control over size? Yes. That's when you guys have control. If it's longer runs and I need number 12, I would put number 8. So instead of number 12 for that circuit, I can put number 10 or number 8. So that's the only 2 factors that you have. You have, as a designer, you have control over the size and the type. That's why we always specify cover, so we don't have to mess with the lower ambiguity in the aluminum. And we always look at the size and up the size if it's longer distances. Typically, longer distances, you're looking at, guys, 100 feet or more. You have, if you have a feeder or a grind circuit, 100 feet or more, you probably should go next step size up without even doing a calculation. That's kind of my rule of thumb, 100 feet or more. Just if you need 4/0, make it 250. Go next standard. Or do a voltage drop calculation, which we're going to be doing, but kind of rule of thumb. Okay. Here's the installation that we talked about, guys. The notorious, the famous installation is this one. These are, you can hear the people saying there's thermal, the term for it is thermoplastic. There's another one that's called thermoset. Can you guys see that term, thermoset? These guys start with R. These guys start with T. Can you guys see the difference? One start with R, one start with T. Now, what's the difference between them? The most common ones are the T ones. The R ones, they can handle more heat. The ones that start with R, they are more robust. They can handle more heat. So that's it. So they can handle higher and lower temperature. So which insulation is better? The one that starts with R or the one that starts with T? R. Why wouldn't we specify R all the time then? Because overkilling, yeah, overkilling, you know. So it's like, overkilling. That's it. And X2, X and R are almost the same, guys. X, HHW, and X, HHW, or XHH. These guys are, the only difference between them is they can handle higher and lower temperature. What happens if you put the insulation in a very low temperature at 25 below like Minnesota? The insulation will crack. Look at your skin in here when you're moving around. We age like crazy here, man, because of that weather. Don't you think so? Instead of having warm, nice weather, your skin keeps contracting and expanding in the winter. Imagine the conductor doing the same thing. So low temperature, very low temperature, guys, is bad for the insulation because it damages the insulation and makes it crack. When the insulation cracks, then contamination, guys, gets into it, and eventually it will fail and short. What's wrong with high temperature? It melts these suckers too. So there's a higher temperature and lower temperature. And typically, guys, they go from 40 Celsius or 50 Celsius down to, I don't know, minus 20 Celsius. So they give you a really big range. If you need more than that, you go to the R's. So when do we use the R's, the thermal set, if we need higher or lower temperature? Otherwise, thermoplastic is okay. It softens and melts if you heat it, and will stiffen if you cool it. This particular one. The R will handle higher and lower temperature better than the T. Am I making sense? So, but what's your default? THHN/THHW. Indoor, outdoor, done. If you have a boiler room, for example, where would you use the R? They use them in the boiler room where it's really hot, and you need a conductor better than THHN. Well, here's your conductor, RHH. So these are a few applications for that. We talked about 310.15, guys. You see this table, we highlight it. You can pick the cover at all times. You can also pick another column for aluminum or copper-clad aluminum. The aluminum is aluminum, material is aluminum. The copper-clad, guys, they fuse the aluminum and the copper together in certain conductors. They're treated, if they're copper-clad aluminum, they're treated as aluminum. The code treats them as aluminum. So we stain the copper. Your choice, like the wire of choice, like I said, your copper is the wire of choice. We talked about this one. It gives you more ambiguity compared to the wire, cross-sectional area. And also, we talked about connection problems with aluminum. Aluminum expand and contract at a higher rate. Loose connection create arc and spark. So, but if you have a well-maintained system, Tony, a well-maintained system doesn't matter. You go torque them yearly, and it's not a big deal. So, we talked about, guys, multiple ratings of the insulation. Anybody can give me one with multiple rating? T, H, H, N, slash, T, H, W. How about triple rating? You will look at some of the insulation, guys. It will tell you also oil. It will say oil resistant. Some of the insulation say THH/THW, right next to oil resistance. So if you put it in an area where there's oil, you can handle the oil. Remember, there's other things other than water can affect the insulation. Chemicals. If you put it in a chemical plant, some insulation, guys, you have to have a cable rated for chemical plants. You know, that's a whole specialty, basically. Okay, we talked about wet location. I always say I like the word that they use for wet location, saturation with water. Subject variable. Here's the word that they use, saturation with water. That's how they define a wet location. Do you see my cup of coffee right now? If I pour it right on this table, would it become wet location? Yes. Is this table normally saturated with water? No. Any room can be wet location, temporary, guys, right? But we're talking about saturation of water. What would you use a saturation of water? Anything in direct contact with Mother Earth, right? How about anything unprotected, exposed to the weather? Anything exposed to the weather? Any places where, like car wash stations? Damp basements are damp location. If it's in contact with the ground, it's wet. But if it's in, yeah, it's considered damp location. Basements are considered damp location. But if you put a cable under the basement from point A to point B, that wet location. Direct contact with earth is always wet location. In the walls of the basement, damp location. I know some basements are floods all the time, so. Okay, we talked about these one, guys. You've seen it before. You're going to keep looking at it over and over again. And here's your Ch rated for 90, dry and damp location, no problem. Heat resistance, flame retardant. Can you see these words that they use? Flame retardant, heat resistant, thermoplastic. When you put an insulation, Jay, in a building, we're terrified here. The National Electric Code is terrified of fire. It's called the fire. The people who write it are firefighters, basically. The National Association of Electrical, what do they call them?
Fire protection.
Thank you. National Fire Protection Association. The word is fire in there. So imagine, every time you put anything that can burn in a building, they want it to, everything will burn, the steel will burn, but they want it to burn, not burn faster, right? So with the test insulation, they want it to be flame retardant, so it holds the flame as much as it could. Eventually it will burn, as well as heat resistance, so resist the heat. So at one point everything will burn, but you are buying time. Why are you buying time? To get the people safe outside. So that's what they want to, with every time you install a system, when they approve it, UL approve it, they want to make sure that for a certain amount of time, a couple of minutes, an hour, whatever, it will not contribute to the smoke and spread of the fire. Eventually, the whole building will, especially residential, will engulf with fire and everything will burn. But it will buy you some time. So that's where your conductors. We talked about THF guys. Look at THF 75 dry, and in a wet location, dry and wet location. If you have THF-2 90 degree in both, XHW, remember that guy also 90 degree in dry or damp location, 75 degree in wet. The one that has a tool. You guys remember the one that has a tool? Always 90 degree regardless of dry or damp. It has a dash tool. That's, don't worry. Throw it outside or throw it inside. It's all 90 degree. And here's all the sizes. Look at, just to give you an idea, guys, THF, you can buy THF up to a size, look, 1,000. All of them. Now, if you need to go higher than 1,000, your XHW take you all the way to what? 2,000. That's a lot. That's a big boy like that guy there. And this is a 2,000. Any comments, guys? Any questions? Comments, questions about the installation? This is directly from the table. This is coming from this table, guys. We looked at it the other time. 310.104a. That's where this info is coming from. We talked about the heat is the enemy number one of electricity, guys. It degrade and destroy the installation, and then it will short. Ambient temperature, that's why we have the ambient temperature correction right in here in this table. And we talked about this one in a couple of, we'll show you a couple of examples here. There's one thing that called, okay, so we know if the ambient temperature is other than 30, you need to derate, right? Now, the smarter than Chad, guys, is they said if you're on a roof, I'll show you an example. If you're on a roof, you also have to derate based on the roof. Do you guys remember when we highlighted that one? I think last time when we looked at this table. Could you please go to this table? 310.15b2a. Temperature values that must be added to the expected ambient temperature if you put your system on a roof. So the way these, let me see if I can. My computer is waking up. I have to go through all this one to get me where I want. But we have a really nice application of a roof. There you go, right here. Do you guys see that one? Do you see these conduits? If you put the conduits in the roof, you put the conductor right through them. So they will be exposed to the sun directly hitting them. That's heat number one. Then reflected heat from the roof. That's heat number two. And anybody can tell me what heat number three is? No? The current going through the conductor. So this conduit is being cooked by three sources of heat. The heat inside the conductor, which is you can have nothing to do about it. I mean, they can't change it. The heat from the sun, unless you want to put an umbrella on top of it or something, you can change it. And the heat reflected from the roof. So they discovered, guys, over experience, that these conductors will be cooked. So how do you do it? If the ambient temperature in Minnesota, let's just say 90 degrees Fahrenheit. And I want to say this, can you guys see that the height here is 6 inches? Can you guys give me the adder, please, from this 6 inches adder from the table? How much do you have to add temperature-wise for 6 inch? Can you guys see that? Everybody can see the table? This is table, everybody in the right table? No, not this one, not this one. Go, 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 go. Yeah, that one. The one underneath it. The one underneath, the one you highlight. Yep. Did you guys? Six. Did you guys find the ambient? 70 degree. Give me the Fahrenheit, please. 30 degree Fahrenheit. Can everybody approve, guys, that if you put that conduit 6 inches above the roof, you have to add 30 degree Fahrenheit to your ambient temperature. So no problem. So now 90 plus 30, that will get you 120 degree Fahrenheit. Now when I derate, I have to derate based on what? When I derate, instead of derating based on 90, I have to derate based on what? 120. 120. Based on 120. That's guys what this table is all about. Okay. Everybody knows how to use this table, guys. 310 of 15B3A must be applied. And adjustment factor for more. If you have more than 3 kinds of conductor, guys, we talked about this one, how you can use this to find the derating factor, right? If the ambient temperature is different, you also have to use add it. Look at this. If your conduit, guys, is 24 inches or less, do you have to apply the bundling? No. We derate based on 3 conditions, gentlemen. Temperature, easy, right? If the temperature is other than 30 degrees Celsius or 86 Fahrenheit, you have to derate. Number 2, if you bundle, you put more than 3 circuits in one pipe. That's bundling. And number 3, you add more temperature if you put the conduit where? On a roof, commercial roof. You have to derate it based on temperature, but you add more temperature when you derate. Now, what happens if your conduit is 24 inches? I nibble 24 inches. Do I have to? And I have 30 carrying conductors. Carrying conductor. Do I have to derate if this conduit is 18 inches? No. They call it nibble, guys. If it's a nibble, you don't derate. They assume it's short enough. Would that be 2 feet? A little bit more, maybe 2 feet. So that's 24 inches. You can fill this one as much as the code allows me to fill it, guys, which is 60%. No derating, no problem. I can put 14 circuits in it. And no derating. Why? It's close to the end, and the heat will skip from this side and from this side. Now, this was part of a 50-foot section or 30-foot section. It will take a long time for the heat to skip to the end. Now you're talking about might as well just use surface mounted raceways, or better wiring system then will be cable tray. Cable tray, they don't have to have a cover, so they just open up in the air. The reason why we use these for physical protection And for physical protection, they have to be tight to protect them from the elements and what's not. So it would be interesting to have a conduit. I'm not aware of a conduit that has a holes in it. It would be a good wiring method because it will protect you. You just put little holes for the air. You should consider that idea. Yeah. It might compromise a little bit the equipment around a conductor, but if you put smaller holes, um, it shouldn't be. It will air it. Then you can. Now you don't have to derate because the air will skip. Consider writing a proposal to the National Electric Code 2017. It's coming soon, man. 2017, it will be around the corner. Okay. Now what happened, guys? Okay, here's a cable. This cable, from here to here, the temperature was 110 degrees Fahrenheit. This is from here to here. Then from here to here, the temperature was 85 degrees Fahrenheit. Could that happen where the same cable is exposed to different temperatures? Could that happen? Yeah. Here's what they tell you. Now, what would you do? Which temperature are you going to use? 85 or 110? Well, here's the 10%. If the section, which one is the worst? 110. Look at the 110. Okay, that's because that's the worst. Now look at this section here. If this section is 10% or more of the overall run of the circuit, then you apply this guy. And if it's, if it's 10% or less, that section is 10% or less, then you apply this. If it's more than 10%, then you have to apply it. If it's more than 10%, you apply 110. You derate. If it's 10% or less, you don't derate.
If 10%, 110 is 10% more than 85.
No, if the length, we're talking about the whole length. Okay, let's take an example here. Suppose that this was 100 feet. From here to here is 100 feet, right? 100 feet. What's 10% of 100 feet? So 10 feet here and 90 feet here. 90 feet, okay? In this case, which temperature would you use? This guy, because it's 10% or less. You see what I mean? 10% or less. 10% only, 10% of the length or more. So permitted length entering the higher temperature is not more than 10 feet or not more than 10% of the total. Okay. So not more than 10% or not more than 10 feet. Sometimes also they use the 10 feet. Now not more than 10 feet. Also, look how if it's not more than 10 feet, you can't. Now look at this. Now you have 1,000 feet. Let's use an example. 1,000 feet. Same example. 1,000 feet. There you go. 1,000 feet. What's 10% of 1,000 feet? 100. 100 feet. Now, 10 feet, not more than 10 feet. Now, which one am I going to use? 110. Thank you. Two rules. 10% or less, or 10 feet or less, whichever comes first. So, am I making sense? How am I going to? So, first you take 10% of the 1,000, give you 100. Okay, no problem. Then, ask yourself, is this 100 10 feet or less? Because there's another rule. It says also it cannot be more than 10 feet. That section cannot be more than 10 feet. Is it 10 feet or less? No. If it's no, then which temperature you have to use? 110. So that's kind of splitting hair a little bit.
100 feet from the 10, and then we could use the 85, right?
Yes.
And with 70 and 30, we use the 110, right?
If it's 70 and 50.
70%.
Which table are you using?
These are under the table. This should be from under the temperature table, guys. Notes. Notes under the rating table. Which one would that be? I don't have my the rating temperature, which is 310.15 B17, I believe. Yep. I don't have my. I forgot my code book at home today. So The Bible is. I was reading a section last night and I forgot I sitting in the living room.
I still don't see one of those.
Okay, so the 10%. I don't want to. I'll show you that one in a second, will you? Because I don't want to. I just want to keep moving on that one. So the idea, guys, is 10% or 10 feet. So take the 10% or 10 feet. Which page? I'll show you that one in a second. I can't find it now. This is coming from 110 dot. I don't have. Okay, you guys are. Let me go to the code here. I have the other code. All right, so let's go. Where am I here? This will be 13. Perfect. 310. Okay, here's my 310, gentlemen. Okay, everybody can see the ambient temperature derating. Did you guys highlight this table? Okay, everybody highlight. You knows how to use it, right? Ambient temperature. 24 inches. Here you go. I would like you guys to adjustment factor shall not apply to underground entering the blood trenches if those okay. Adjustment factor. Some of these 10% should be here. Blah blah blah. The adjustment 60%. Okay, so adjustment factor shall not apply to underground cables. Okay, where did we get that one? You got me. All right. Bundling and the ambient temperature, right? It is. I can't remember now. 10 feet. Reinforced 10 feet. Okay. And this is the justification, guys, right here for the ambient temperature and temperature installation. No, it's not. Blah, 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 blah. I can't find it. And then, of course, where I highlight it, having a negative 310.6. Which one? 310? 310.16. Okay. Table or 310? No. 310.60 here. We're two different temperatures. We're two different. Okay, this is the for the high voltage though. There's one exception like this for the low voltage. You're right. There's one exception for the low voltage. Or something. I can't. Three ten dot 15.
Yeah. And it's 310.15.
A1 or A2. So here you go. Thank you. Right in front of us. Where two different ambassadors apply to adjustment, blah, 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 10 feet and 10%. Can you guys see that? I'm not down with Thomas now. Or you want to move? Thank you. There you go. All right. So, took me a while. I'm sorry. I haven't seen it for a while. I don't have my highlighted code book.
I just want to know where you're getting.
No, I hear you. I hear you.
110. That's what I want to know.
exception. Should have looked at that.
Very good.
Okay, should have looked at that one. Okay, gentlemen. Um, so review the rating. We talked about the rating, installation, ambient temperature, more than 3 Kelvin conductor, single conductor. Okay, when you derate, here's the things that you need to take into consideration for derating, guys. From this table. Oops. From this table. Ambient temperature. We talked about ambient temperature. More than 3 Kelvin conductor. Also, single conductor in cable trays. We're not going to stack together in cable trays. Where's my cable trays? Bundling of conductors, more than 24, or for link greater than 24. And there's exposed to the sun also, that will get you. I'll show you a couple of pictures that's really interesting that we do. How come it affect? Okay. Conductors dual. Keep all conductors together. I'll show you the derating, guys. One more thing I want you to take into consideration, guys. Keep all conductors together. This is very, very important. So if we have a conduit right here, and I phase A, phase B, phase C, neutral, and ground. So here's phase A, phase B, phase C, neutral, and ground. Can I put phase A and B in one conduit and C and neutral and ground in another? No. Moving forward, when you have a circuit, all the conductors of the same circuit must be in the same cable or conduit. Making sense? All the conductors of the same circuit must be in the same cable or conduit. Meaning, if it's a three-phase circuit, you have to put them in the same cable or conduit. You cannot put one phase in one conduit and the other phase in another. Why? Because of induction heat. When you put them together, there's induction heat, guys. You create the magnetic field. The induction heat here will be eliminated or reduced if you put all the phases together. The magnetic field of all these phases will kill the induction heat. There are stories, guys, of people putting one conductor, one phase in a cable like this, and it will glow, literally glow. The conduit will glow. You're creating an induction heater, basically. If you put one phase right now here, and you energize with a say 100 amp, and you come after a while, this one will be glowing. You created a heater, induction heat. So if you put all the phases together, the magnetic field of each one conductor will kill the others, eliminate them, so you don't create an induction heater. Same thing in the cables. So that's why we group all the circuits together, always. We talked about continuous load, guys, and what do you do when you have a continuous load, gentlemen? 100%. You will multiply by 100%. If it's not continuous, you leave it alone. We talked about overcomputation device, guys, extend equipment serving, selecting the overcomputation device. This is very important table. I would like you guys to pay a lot of attention to it, if I can get you for a second here. Circuit component. If you can highlight this one and you know it, you will never go astray again. Let me walk you guys through this table. You have it. Okay. Then these are the type of loads that you're going to have. The type of load that you're going to have. I'm going to start with load number one. Number one. C for continuous, guys. Continuous load. If you continuous load, when you size, this is the size and rating type of cable. Continuous load. Okay? So what does C stand for? Continuous load. And then if it's continuous load, what do you multiply to size the conductor? Conductor. Conductor size, what do you do? 1.25. Minimum overcomputation device. What do you do when you size the overcomputation device? Can you guys see that? The overcomputation device, 1.25. If it's not a standard, where do you go? Next size up. Okay? Let's take an example. I have a load, very simple. I have a load 10 amp. 10 amp load. I want to size continuous. 10 amp load continuous. Okay? Let's size it based on this. So do me a favor, take the 10, multiply it by 1.25, what do you get? 12.5 amp. Take this one to 310.15 B16 table. That will get you conductor. Which conductor size? Two conductors number 14. AWG. Can you guys see that? Right? Go to the table, it will get you number 14. So this conductor is what? Number 14. Done. Next, you take the same 10, multiply it by 1.25, gets you 12.5 amp. Take this one to 240.6. You guys remember 240.6? What does that give you? The overconduction device. What's the next overconduction device? 15 amp. Gentlemen, this circuit is a 15 amp. That's how you do this one for continuous loop. You multiply from by 1.25, both of them. Okay? That's your continuous. Number 2, I'm going to jump a little bit, guys, and go number 2 to non-continuous. And stand for non-continuous. Can you guys see that? Does that make sense for continuous load? How to size the conductor and overconduction device? Makes sense? 1.25. Now, non-continuous. For non-continuous, what do? Not less than the load, next size up. If that load was non-continuous, let's do it if it was non-continuous. Okay. So do you have to multiply by anything if it's non-continuous? Okay. So size the same load, non-continuous, 10 amp. So then this cable have to be 10 amp, and this have to be 10 amp. Now, do they make a 10 amp circuit breakers? Are there 10 amp fuse? I thought there is a fuse 10 amp. Look at the bottom, guys, in that 240.6. 240.6.
I thought it was an exception ones at the back for additional 10 amp during fuse shall be 1.6.
Thank you. Thank you. There are 10 amp fuses. There are 10 amp fuses way at the bottom. So, look what happened. Now, you don't do this one typically. At the bottom. Here's my fuse. And that'll be a what? A 10 amp. If I want to fuse it, that'll be a 10 amp. Typically, we don't program this at 15 amp current circuits. We don't. But that's how your system would be. And the conductor, the conductor here, we can't go lower than what? Number 14 anyway. Any comments, guys, about non-continuous, how you size it? Straightforward, no multiplication. Just go to the code in 2 tables. Okay. These are the single most important thing, guys. Very, very important how to size them based on continuous, non-continuous. Cool? Questions about continuous, non-continuous? Now, Jerry, you might say, well, 10 is not making a sense, Chad. Well, take 90. Take 90. Now, will it make a sense? Yeah, 90 times 1.25, big number than 90, right? That's because 10 is just a smaller number that we end up with things. But if you take 90 or 100 continuous load, it makes a big difference. Okay. The third load, John. The third load is motors. 3. I'm going to go to 3. I'm skipping that. Motors. For conductors, what do you do for conductors for motors? 125%. How about for overconduction device? You guys just came from my friend Chase. The overconduction device for motors. Motors are weirdos, I call them. Motors, guys, need an air rush. When you start them, because they have coil, Gary, they suck tons of current. They call start current. And you guys have just came from the motor lab, a lot of you, and you know what a starting current of a motor, right? You energize the coils dead, and it sucks a lot of energy for a very short amount of time. Because of that huge energy for a very short amount of time, they allow you to oversize the overconduction device. The options will be right in front of this table. You guys remember that table? I can summarize it for you. If it's a fuse 1.75 or 3, these are all multipliers, or 2.5. These are the most common ones that we use. 3 multipliers. 1.75, you guys used it with Chase. That's dual element time delay fuse. If it's non-time delay fuse, 3, and if it's a circuit breaker, 2.5. Please highlight this table, table 430.52. Please highlight this table. We'll be working on that one too, guys. Okay? Now, this is 430.52, table 430.52. You guys should have that one marked from last year. Yeah. Yes, absolutely. And we will use it a couple of times. Okay. Now, do me a favor, right here. Can you guys write here? Typically, next, if it's not a standard, they allow you to go next, higher. almost always. So you end up with 33.3 amp fuse. Do they make 33.3 amp fuse? They allow you to go to the next standard 35. Okay? In all of them, guys, in all of them, you're allowed to go to next standard. In all of these. Okay. So these are motors. The last one, gentlemen, and I'm not killing you here. Number 4, hermetic motor compressor. Now what the heck is that? Hermetic motor compressor. Hermetic motor compressor is anything that have the chilling, anything that's chilling basically, chillers and air conditioning, refrigeration cycle. Anything that has some type of refrigeration cycle, guys. A compressor that compress the refrigerant. These guys, a special type of motors that they they cool the motor while it's compressing the refrigerant. But because the motor is cooled by the refrigerant that it's compressing, they allow them to work harder than other motors. It's the only difference between the two. The code have different articles for them, guys. So these guys are Article 440 that talks about them. Okay. Now, how do you size a conductor? There's something called minimum circuit ampacity, minimum circuit ampacity, and maximum overcurrent protection device. And these two guys are on named plate. So do you have to do any math? No. They will tell you the air conditioning that you need, Jay, your air conditioning. If you look at the nameplate, it tells you two things. It tells you it needs 2 conductors, the minimum ampacity most likely will tell you like 30, probably 28 amps. Give you minimum circuit ampacity 28 amps. And the overcapacity device 30 amps. So that's directly on the nameplate for the AC. So what do you do? So here's my AC, gentlemen. It says 32 amps, minimum circuit ampacity, and 30 amps fuse or circuit breaker. So you come over here and you put fuse or circuit breaker. So you put your circuit breaker here, and what conductor can carry 32 amps? No multiplication, nothing. Just take the 30 amps. I can guarantee you it's number 10. I'm sorry, not 52. I wanted 28. I'm sorry. To make it typical. 28. 28. Number 10. 208, 230. Yep, that's a range of voltage. So you can burn it from 208. Yep. Remember, 230 plus or minus 10%. 230 plus or minus 10%. Yeah. Most of the equipment that they use in the US, guys, because we have multiple voltages, they allow you, especially 208 to 240, very close to each other. They make one piece of equipment that can work from 208 all the way to 240. Any voltages, which is only 2 voltages, either 208 or 240. So a lot in the 3-phase system also, they can they use them. They say 208, 240, single phase, 3-phase motor. So you can power it 208 if you want to, or 240, it will accept it. Now, if you go to 480, you have to rewire it. So they allow you a range of voltages. Okay, gentlemen, the last thing is plug. Cords unplugged. These guys are a big deal because we have no control over them. Cord unplugged, grind circuit, not less than overcapacity device, not less than the load, not higher than the conductor ampacity. The cord unplugged. These are when you plug things, and we typically don't do this one until we do the industrial. When you start having machines, plugging them into. So, so the circuit, if it's a cord unplugged grind circuit, not less than overcapacity device. So if you have 50 amp, not less than 50 amp, not less than the load it has to handle, and not higher than the conductor ampacity. Any comments, guys? Any questions about determining the overcapacity device and the conductor? Probably this will summarize the whole sizing for you guys, the whole sizing business. And I know I killed you a little bit here. Talk about these. We're not going to talk too much about these. Continuous load. Okay. All right. What I want to do, guys, with these after that, I'm going to walk you through an example that they have in I'm going to give you, if you guys don't mind, just 5 minutes, go stretch, and I'm going to walk you through a couple of tables. That's really nice. They did exactly what we did right here, through a table. I'm going to walk you quick through them, with derating and what's not. Should we have 5 minutes, please? Thank you. I'm just going to finish with these. For derating purposes, guys, this is the one that probably a lot of people misunderstand. So when we derate, if you put a pipe like this, you put more than 3 hots in it, you derate, right? If you put a cable, if you buy a cable like this with more than 3 hots in it, you derate. These are easy to remember. Now, what's not easy to remember, if the pipe is 24 inches or less, do you have to derate? No. Now, if you have multiple cables, look at this. You have, this is an unknown cable, not unknown cable, Robbins. If you have multiple cables, can you just say group together, bundle together, right? Then you have to also derate. You also have to derate if they're more than 24 inches. If they're more than 24 inches. If they're more than 24 inches. Bundle together, if they're more than 24 inches, you have to derate. If you have AC cable, this is an MC cable. If you have an MC cable and more than 24 inches, you bundle them together like this. More than 24 inches, you also have to derate. You also have to derate. But these guys, you have to derate them. Look at how they can get away. You have to derate them. Look at this one. If they exceed 20 hots. So take this, gentlemen, MC cable right here. Here's an MC cable. How many hots? 1, 2, 3 hots in it, right? 3 conductors, 3 hots. Okay? 3 hots. 20 divided by 3 is what? 20 divided by 3 says 6. 6 point something. Okay, so 6. I can put 6 cables like this. 6 cables. So right here, I can put 6 AC. This is 4 conductors, number 12, AWG. This is, you're looking at it right here. 4 conductors, number 12, 3 phase. 6 of them grouped together like this, and I don't need to derate. Why? Because in each 6, how many kind of conductors? This has 3. 3 times 6 give you what? 18. Am I less than 20? 20 or less? Yep, you're good. You add 1 more. You add 7. This becomes 7 times 3, 21. Now you're screwed up. So when you bundle of these, you can't bundle more than how many of them? 6 of these. Does that make sense? Bundle them. They use them a lot in commercial. You group them together and bundle them. Or you put them in the rack and you bundle them. If you separate them by 1 cable, you don't have to worry. If you have a rack or something and you put them like these, move them with a space, with 1 space in between them, so like this up in here, and not grouped. They're sitting side by side on a rack or whatever, then you don't have to do anything. That's when you bundle them. You've seen them, guys. They bundle them. Sometimes they grab them, hold them. Then you can't put more than 6. And 6 is a lot. You know how many 6? I guess 6. If you take 6, 18. These are 18 circuits. Just to give you an idea what an 18 circuit is. This is 18 circuit, guys, right? So 18 circuit. Do this math. Multiplied by, if these circuits are 20 amp circuits, right? This is 18 20 amp circuits. Number 12, conductor number 12, 18. Let's do receptacles. If you're doing receptacles, you can put close commercial receptacles. You can put 6 receptacles in each circuit. So multiply this by 6. And you can see how many receptacles you can feed on these circuits. How many? 108 receptacles. If you're doing lights with these circuits, 18 circuits, multiplied by, if you're doing light, typically what we do, and I'll do over the math, guys, we put 18 lighting fixture like this on 1 circuit. And I'll go through the math. Multiply this by 18. What would that give you? 324 light. So you can put 324 lighting fixtures on 6 circuits. Huh? I'm sorry. Yeah, 324 fixtures on 20 amp circuit like this, number 12. Does that make sense? It's a lot of juice coming out of it. So okay, but pay attention to the derating on these. Um, a lot of circuits. For the neutral guys, this is just a few things about the neutral conductor. Um, we're doing three-phase, so please, as you move with three-phase. This is typically 208/120 volt three-phase system. 208/120 volt three-phase system. Now, what happens if one phase is not energized? The neutral will be carrying what? The same amount of amps. Look at this. This is phase A, phase B. This is my neutral, and phase C is sitting right here. Phase C, and it's not connected to anything. So if phase C is not connected to anything, guys, then the neutral will carry the same amount of current that goes through the other two. That's typical for a three-phase system. This one, we talked about it a lot. I thought I've never seen it in a better shape, guys, connected. So please highlight this. And we talked about it. Here's where most of the engineering stuff would happen. I would like you guys to highlight this because probably this is where equipment permitted at a higher rating of conductor is listed and identified for higher use. I want you to highlight this one. This one is most of the engineers use this particular one. The lugs, can you guys see the lugs here? Are rated for what? 75. The circuit breaker is rated for what? 75. And the conductors are rated for 90 or 75. That's most of the equipment in engineering equipment will be 75, 75. So when I size my conductor, I size it based on what? 75. That's default for engineers. Default for engineers. Am I making sense? That's your default for equipment. Three-phase. Huh? Are you highlight it? Yep. Which page is that? And which page? 75. Good. Yeah. Now, the second one that engineers also is right. The one underneath it is that's engineers. Motors. All your equipment are rated for what? 75. So everything is 75 degree. So which column are you going to go when you're dealing with some motors? 75.
So that's engineer standards or industry?
That's engineering standards, and also this is called B, C, or D. From this section, it will tell you, go ahead and do it. This one, guys, typically equipment that we use for three-phase. When you deal with most of our equipment are three-phase equipment, engineers. So three-phase equipment, almost always rated, the lugs are rated for 75. Cables, we decide the cable is going to be 75 anyway. We decide the cable. The lugs is the issue. The lugs always the issue because we don't decide the lugs. If the three-phase equipment, 99.9% of the time, it's 75 degree rated, the lugs. Okay? So everybody can see why the engineers defaulted to these two for motors and, okay, now, the challenge happened is for circuits, these two, unless you know otherwise, here's your cutoff. Unless you know otherwise, here's your cutoff, my friends. If your equipment rated 100 amps or less, or number 14 or up to 1, it's defaulted to 60 degrees. So this is defaulted to 60 degrees Celsius. If conductor with a higher temperature rating, but 60 degree ampacity will be used. So basically, this is your default for typically single phase equipment. Your default is 60 degree column. But look at I want you guys to highlight, and we talked about this one, highlight these two in particular, right here. So why it forces you to go. If your equipment is 100 amp or less, or your conductor is number 14 all the way through 1, you default to where? You default to 60 degree column. You default to 60 degree column. Okay. Any comments, guys, about these? So these are the two bottom ones, so if anybody asks you when you're designing, which color do we go by default? 75. Where do we go to 90? Do we go to 90? Only for derating. We don't size based on 90. We derate based on 90. I can't emphasize that enough. We derate based on 90, but we do not size based on 90. When do we use a 60? If we know that the equipment are rated or the conductor, lugs or conductors, we control the conductor, guys. So don't ever think of conductor 60. Why? Because we control it. We decide. We use MC cable, THN/TSW dot. I mean, so we control the conductor. This piece here is controlled by us. The only thing that we don't control is the lugs. If the equipment is three-phase, lugs always defaulted to 75. Don't worry about it. 75. If the equipment is single-phase, then if it's 100 amp or less, 60. If it's more than 100 amp, 75. If the conductor landing on it, is number 14 all the way to number 1, and you don't know what the amps are. So a piece of equipment, I have no idea what the amps, but coming out of it is a conductor that's number 12. So when you size it based on what? 60. These are the default by the code. The code default. Okay, and this is where the rest of them, guys, is 75. It's more than, we just talked about this one a second ago. If it's more than 100 or more than number 4, number 1, you default to 75. So this is the one with over 100, can you see? And over number 1, larger than number 1, 75. To summarize, guys, three-phase equipment, 75. Equipment, 100 amp, more than 100 amp, 75. Equipment that has a cable larger than number 1, 75. So when do you use 60? You really use 60 in very limited residential applications. Almost always, when you use this cable, guys, when you use NM cable, or UF cable, these NM cable and UF cable, these are 60 degree. You can't go to 75 with these cables. Always. Why? Can anybody guess why? They're residential. They're single phase. They're used for single phase mostly. We cut that one. As we move on, guys, I don't know if the ones who have been with us, guys, if Chase emphasized the three-phase branch circuits. When you design, guys, when you design systems, we design three-phase, almost always, especially engineering projects. And when you design three-phase, you always run with three-phase branch circuits. They're called three-phase branch circuits, okay? What is a three-phase branch circuit? Three-phase branch circuit, you're looking at it right here, gentlemen, right? Three-phase branch circuit. So you put circuit breaker right here, 20 amp, circuit breaker right here, 20 amp, circuit breaker right here, 20 amp. They have to be tied together with an approved handle, which looks like this. Basically either one handle for all of them or 3 handles tied together, 20 amp. This is 15, but 20 amp. That's how you run them. And when you, this circuit will be basically, if it's an MC cable, so there will be number 14, I'm going to say 12, because we don't use, say number, this will be number 12-4 MC cable. What is 12-4? 12-4, you're looking at it right here, John. That's called 12-4, MC cable 12-4. 4 conductors. Do we count the ground? No. 4 conductors. That's it. 12-4. Okay, what do you do with each? How many circuits is this? How many circuits is this system? 3 circuits. 3 single-phase circuits grouped together. Are they sharing the neutral? Yes. They share the neutral. Now, if these are fluorescent light, a fluorescent light are, remember the harmonic and nonlinear, the slobby eater like my son? They don't eat. When they eat, their ears and nose eat with them. These are the slobby eater. The slobby eaters are the harmonics. Fluorescent, why are they slobby eater? Because they have electronic ballast inside them. Anything that take AC to DC, guys, is slobby eater, harmonic. Long story, who cares? Who cares when you put 10 amps here, 10 amps and 10 amps here? This should have been 0 amp, right? If that was a motor, if these were 3 motors, 1, 2, 3, shared neutral, the neutral would carry 0 amps. But because of electronics equipment, they digest electricity in a different way. Long story short, they instead of canceling each other to 0, they add each other sometimes, or they get you the 10 amps. So who cares? What's in it for you guys? You can't derate the neutral in this case. You have full neutral. That's all. So 10 amps here. So this in this circuit, guys, you can have 10 lights, and this circuit's 10 lights, and in this circuit's 10 lights. So on this system, I can have 30 lights. 30 fluorescent lights, like right, this one above your head on this circuit, on this system, on a cable like this. 30 of them. How many we have here? 1, 2, 3, 4, 5, and another 5, and another 5, huh? 15? 14? 15. 15. So all this lights in this room and another room on this cable. Can you imagine the gravity? Just to give you an idea how powerful this 3-phase circuit is. Yes, sir. One cable right here. But remember, this is a 14, a 12, 4. 3-phase and a neutral. Now, this is if the voltage is 208. If the voltage is 208/120. We can put how many circuits, gentlemen? 30. Now let me up it for you. See the gravity of. Let's use the same cable, guys, and use a voltage 480 to 77. Same system. Change the voltage. I'm going to change the voltage to 480/277. The only thing that you need to do, Patrick, now when you change the voltage, you're going to call the manufacturer, ask them for a 277 ballast. That's all. Same fixture. And actually, most of these fixtures come with something called multi-voltage ballast. It says multi-voltage, so if you have 120, plug it in, it works. If you have 208, plug it in, it works. If you have 277, plug it in, it works. And some of them work on 600, not these outside ones. So multi-voltage. Now, but look what happened if you raise the voltage. Double this, times 2. How many I can get? 60 lighting fixture out of this. I'm not saying you have to do it this way, guys. It will be a fool to put 60 lighting fixture in one multi-wire branch circuit. Can anybody knows why? What happens if you have a short circuit in one of them? Right? The whole floor is down. The whole floor is down. That's when we circuit, even though we can allow to put a lot of branch circuits. Sometimes they haven't taken into consideration. For example, what we do is a good idea is to put 2 circuits in one area. So this area, this room and the other room, we can put them in 2 lighting circuits. Half of this will be in one circuit, and the other half in another circuit, as well as the second room. So if one circuit goes down, you got it. Now, if your size based on LEDs, do me a favor. If your lights are LEDs, times this by 2 again. 120 coming out of which cable? That cable, you're looking at it. 120 light fixtures coming out of this cable. If they're LEDs. Why LEDs? Because LEDs, guys, barely take half an amp, each one of them, or 0.5 of an amp to burn it. They don't burn a whole lot. That will give you guys a gravity. Why, when you go to an airport or other locations, they start burning the fixture at what voltage? 277. Now, unfortunately, we can't burn the receptacles at 277, right? The receptacles, I have to use 281/24 receptacles in the U.S. We have to. We have no choice of using 277, right? For regular receptacles. Okay, so we got that gravity. This is your single-phase system, guys. You're familiar with that system. For single-phase system, this is for the dwelling only. We don't use that one. Also, multi-wire branch circuits, 10 amp, 10 amp. Look at the neutral. The neutral will carry the difference between these two, right? In a single-phase circuit. In a single-phase circuit. Do you guys understand the difference between a single-phase source of power and a 3-phase? You work with utilities. This is coming out of a utility-owned transformer that looks like this. So this is 7200 typically volt and phase A. What they do, that's a transformer. That's a big transformer. in one. That's what you see, that little barrel sitting there, you know, container. Now, and they ground one phase, or they take it typically to the other phase. This is your transformer. Then what they do is they take a phase and they split it. This is called split phase power system. One phase, they split it into two hots. Drove me nuts when I ever saw it, the first time I saw it in the US. Nuts. Is this single phase or three phase? What the heck is this system? It's a split phase system. One phase, here's phase A. Can you see it coming from the utility? They split it into two hots. You would never go, you never go stray again if you understand it this way. One phase split into two with a neutral. The difference between that one and the one before, look at the one before, that's a three-phase system. This is completely different transformer, different systems. They're giving you inside your building, they're giving you phase A, phase B, phase C, and a neutral. This is your side. The utility will have the same thing here. This is their transformer, and that will be typically 12.47 kVA or 13.8 kVA. So 13,800 volt on the primary side, or 12,470 on the primary side, and the transformer will be sitting on a pad like this, big fat fluffy one, and the phases are phase A, phase B, and phase C. Do you see the difference between the single phase and the three phase? Cool. I know, Jay, you work with it, but the rest of you, major difference, guys, between this type of system and this type of system that we use in residential. Completely different. So, comments, questions about this one? Now, if you have a commercial industrial building, and when you talk to Excel, you want to be shooting for something like this. Almost always a bigger building that give you a three-phase system. Three-phase system is more superior than single-phase system. Better performance, more superior, and so forth. Okay, so moving on. This is just so we talked about the system. I can't emphasize the importance of the power system because if you guys don't understand him, it drives you nuts. Do we count the equipment around conductor when we derate? Do we count the neutral? Do we count the neutral? The neutral? The answer is no, except if it's carrying harmonics. So when you're feeding a lighting fixture like this, it's harmonic. Now these, look at that. Now these will change into, instead of 3 hots, for derating becomes 4 hots. The neutral is carrying current. That's where they kind of screw you up with the neutral. But the ground would not count. If you have 24 inches like this or less, do you derate when you fill them? You can fill it, no derating, no problem. We talked about this one too. Okay, so luminaires. So we talk about these. So 3 conductors for basic calculation. Oh yeah, if you have a 3-way switches, like this, 3 and 4-way switches. These are 4 conductors, but they consider them 3. Anybody knows why? When we have 3-way switches, one of them will always be dead by the design. So if you have 2 circuits, guys, in the same pipe, look at this, 2 circuits in the same pipe, they will never be energized at the same time by design. You just drop one circuit, the smallest circuit, in terms of bundling and derating. So these are a few derating rules. Inductive heat, we talked about the inductive heat, guys, why you have to bundle it together. If you put a cable, when they bring a single conductor cable into an enclosure, guys, you know what they do? They don't bring the bigger cables. They don't bring them in one hole by itself. They cut a big chunk and they bring all of them in the same cavity. So if here's the bottom, one way is to bring the cables, bigger cables, typically bigger cables. Here's phase A, phase B, phase C. You never want to do that. If you do it, and this is metal, especially steel, you're going to come over there and it's going to be hot, really hot. You're doing inductive heat. So what they do to avoid the inductive heat, they go cut between these. They cut the holes between them. So this becomes basically one big hole when they bring the phases. This is, you wouldn't see that unless you're dealing with something like 1,000 kcm or more, bigger conductor, single conductor cable. So what do we do with the circuit when you guys group all the circuits together in one conduit to one cable? Always, always. Talked about the motors. The rating of the circuit is the rating of what? The overconduction device, right? So this is 30 amp circuit. The rating of the cable is the rating of the overconduction device. 30 amp circuit, lighting, heating, and motors. Oh yeah, motors are weird. Did I tell you guys motors are weird? Look at the conductor can be smaller than overconduction device. Is this okay? Yes. For motors. Anybody knows why we oversize the motor overconduction device? Because we're sick of every time we energize it, it trips. Trips. Okay, so that's all that. And the last thing I want to do, I know I killed you today, but you guys can surviving. This is wiring coming to the building. Talked about that one. Insulation. I want to go to the table. Okay. Okay, I would like you guys to, could you please go to this page, in your case, page 82, please, page 82. Thank you. This is a summary of what they did, guys, to do calculation, bright circuit calculation for the project, the commercial project that they did. Okay, let me walk you through this. It's a very intense table, very intense table. I'm going to walk you through the following. Number one, let's talk about style I. What's style I? Look at here, they're fixtures. And you see, let's look at the first one. This is a style I fixture. How many of them do I have? 27, that's a number. Load each, what's the volt amp for each one of them? 61. What does this number mean? These two multiplied by each other. So take 27. So here's a 27 of them multiplied by 61. That will get you the total. Can I have a thumbs up, Chad? We know how this works? Yep. 27 fixtures, each one of them is 61, multiplied by each other gets you 1647. Cool. Now the load time, what does C stand for? Thank you. Who said continuous? I don't have candy to give you. Next time. Continuous. Continuous. I'm almost done. This is the last thing, guys. Okay, load modifier with continuous load. What does that mean? 1.25. So, okay. So, and ambient temperature. This is, the ambient temperature will tell you, are you in a hot climate? It looks like we're exactly where we should be. Do we need to worry about temperature? 30 degree 86? No, don't worry about it. Okay. Correction factor. Since the ambient temperature is 86, my correction factor here will be what? 1. Meaning, don't worry about it. Does that make sense? So we see the ambient temperature is my ambient temperature.
Let's say it was like 2 for the correction factor. What would you mean?
It wouldn't be 2, it would be less than 1, like 0.9, 0.8. That's coming from the derating table based on temperature. So if the ambient temperature says 90, well, not 90, let's just say ambient temperature is 110. Do you guys remember that table? For 110, there's a derating factor. That will be from, I can't remember which one of them. 310.15b something. One of these. Okay. So since the ambient temperature is not hot, do I need to worry about derating? No. No derating. Let's go to the next. Carrying conductors. Now, did you find it?
So you're saying if it would be 110, it would be 0.87?
Thank you, sir. Okay, now let's say, then you're going to ask me, what type of insulation, Chad? Let's just say Ch. Go under 90 degree, Ch. For 115, Ch. No, right in that table that you were in. Yeah, that's just the 90 degree column. For Ch 90, that will be under, say, 110 degree Fahrenheit. What would be the number? 110? 105.87. Yeah, I hear you. But I wasn't sure if you went to the 90 or the 75 or 60. There's 3 columns. You went to the 90? You're right now, man. Okay, so everybody understand, guys, this number changes with temperature. Okay? Now, carrying conductors. How many carrying conductors do I have? 2. Do I have to worry about derating because of bundling for 2, 3 or less? No. I put a 4, then we're doomed. Okay, then that number here is 1 because we don't derate. Now, I'll pick on you, Gary, again. Now, suppose I have the number here instead of 2, 5. Can you guys go to the table, the next table that gives you bundling? If there were 5 of them, what would that number be? Please. Which 310, not 15, B7 is it, or B something? Go back one, right, the one at the top. Yep. Read it. Read the table.
What do you do
B3.
with 8%?
Okay, now, suppose there were 5. Then instead of 1 here, what do you put? 0.8. Okay? Makes sense? If there were 5. I'll tell you what you do with it in a second. Okay, well, you put 0.5. Then, minimum allowable amplicity. Minimum allowable amplicity, guys, is taking this this number. So we take this number here, divide it by 120, and multiply it by 1.25. That's your minimum circuit amplicity, 17.2. Okay. Then, does that make sense? Take that number, divide it by 120 to get it amps, and then multiply by 1.25. Then go size a conductor for 17.2 amps. Which column are you going to go to and why? You have no idea what the lugs are. So which column are you? We have no idea what the lugs are. So you always default 100 amp or less. Where do you default? 60-degree column. So that's where they got the number 12. 60-degree column, right? For 17.2, 60-degree column would get you what size conductor, gentlemen? 12. 12. If it's 100 amp or less, this is 17.2. 100 amp or less, you default.
You took that 1647 divided by 120
Yep.
times
1.25. Yep. Okay. Everybody got that? 12. Hold you a second. Okay. Now, how much current can number 12 carry under normal operating condition? Number 12. How much current number 12 can carry under 60-degree column? 20. Thank you. Right here. Do you see it? Here's your 20. One more time, gentlemen. You take the 17.2 to 310.15 B16. Jay, did you take him 17.2 to 310.15 B16 under 60-degree column? What size wire do you have for 17.2 amps? Number 12, right? John, did you find number 12? Verify it.
Well, when I did the math, it came out to 30.88 amps. I got 17.15.
You did the math wrong then.
Yeah, it's 1647 divided by 120. Then
Multiply.
that answer, pull it down and start again, probably.
Yeah, then you multiply by 1.2.
75 times 1.25.
Did you guys verify that? Yep.
Right.
Yeah, the first thing you guys take this 1647, divide these two together first, okay? Then you multiply the answer by 1.25.
And then you take that. Well, I think they rounded up.
Did you come up with 17.5?
1.15.
Yeah, they rounded. Yeah, you are picky, man. Wow. Okay, I hear you, but yeah, with amps, you don't want to go less than 0.5 with power amps. Now with Chase and his little PLCs, a 0.0 amp is a lot. For the power industry, a 0.5 amp is nothing. So tell him that, Chance. Okay, now number 12, under normal operating condition, how much current can number 12 carry?
You go to 240.4 dB.
No, it right here, just the table, under 6-degree column. 20 amps.
Well, I'll just double check
The 3 stars will tell you guys.
You want to take that into account, or?
Yes, the 3 stars will tell you number 12 cannot be protected for more than 20 amps. Okay, it's coming. Now the overcome protection device right here. Now do me a favor, take the 17 here, this number, take it to 240.6, and that should give you 20 amps. Right? Yep.
That's your OCD treatment.
Standard ampere rating uses a fixture.
Okay, that's it. Now, you're gonna, because it has a star, now you're gonna go say, okay, number 12. Can number 12 have a 20 amp circuit breaker? Yes.
Using copper, absolutely.
Yes, that's where that star comes handy. You and your stars. You got it. Yep. Gentlemen, the whole table is exactly the same. If it says N, what does N stand for? So do you multiply by 1.25? No. You got it. So you leave it as is. The same thing.
Put in the,
When do we put in the correction factor, or where do we put it? If it's,
Yes. Now let's do an example. Up to this point, guys, excuse me. All the way here, can you guys see there's no correction factor here? No correction factor here. Can you guys see that? No correction factor. Now let's go to a place where there's a correction factor. Okay, let's go to AC all the way down. Oops. There you go. I'm going to go to another example where we have to use a correction. Okay. Let's see. Yes, let's just go. And the rest of them, guys, all identical. Identical. And what does R stand for? Gentlemen, what does R stand for in the loader? R for receptacle. Are receptacles continuous load? Look at the number. No. Receptacles and receptacles are non-continuous load. Are lights continuous load? Yes. Okay. H is hermetic refrigeration, which is basically a chiller or an AC. All right, so everybody knows what the identifier. So let's take one that has a derating factor. This guy, none of them has here.
Air conditioner unit.
Right here. Okay, so let's take that one. It's the only difference. Okay, let's look at this. I have an AC unit. Here's the size of it. It's one of them. 1 multiplied by this give you this. It's hermetic. Hermetic. Do I need, what's that one? What's that column again? This is for load modifier. No modification in it because that's the nameplate. Telling us that's what they want from the nameplate. But somebody goofed up, not goofed up, because it's outside, I need to derate based on this temperature. That's it, right? Can you guys see that? What's the column? 3 carrying conductors, so no derating. The only derating is right here. Can you guys see that? Okay. Now, excuse me. This amp, anybody can tell me where this amp came from? Take this number divided by 240. Can you guys verify that this is what you get? Is it?
35.3.
Uh-oh. They changed. I know this is from the last. Okay.
Well, that's because
Oh, yeah, that first number's
our
different.
calculated, our
Oh, yeah.
VA load is a little bit higher, so it's
Oh, okay. Can you verify on yours that this number divided by 240 will give you that number? Did you guys verify? Is it 35.3? Did you guys no multiplication? I know mine is different. Take the 11,196 divided by 240. Did you guys get 35.3? How much?
because we gotta multiply by.
Okay. Do me a favor. Just do me a favor. Take this number divided by 240. No, yeah, the number that I have. Divided by 240. What did you come up with? How much? This number divided by 240? Any second?
44.6.
So 10725 divided by 240. 44.6.
Or 0.7.
So round it up, that will get you this number right here. 45, right? Right, okay. Now, go size a conductor for 45 amps on the 60-degree column. That will get you this number.
6.
Number 6 or number 8? Number 6. That's why you guys are corrected in.
Number 8 is 40.
Rate is 40.
Yeah. I hate to follow people's examples. Yeah. Okay. I see. I'm gonna use, can you guys give me your example, please? I don't want to do that. I want to use your number, the new ones. Can you give me the number of the KVA, please? Please do it together.
11196.
Thank you. 11196 divided by 240. What do you come up with?
46.65.
46.65?
You can round it up, so.
What?
Well, I mean, they were that type of-
46.7.
Yeah.
46.7 amps. Okay, now, do me a favor. Take this one to 310.15 B16. Under, now, this is an AC unit. They must have the logs rated for 75. Go under 75-degree column. Number 8. Do they have number 8? Is the number 8 an option?
Yeah.
Because it's an AC unit, they must have said that his AC is rated, the logs are rated for 75. Otherwise, if they don't say that, what do? 60. Okay. Number 8. Okay. Everybody's good with that? Okay. So that should be, where would that be? Number 8 is right here. Number 8. 4. Okay. Now next, take number 8. How much current number 8 can carry? It's, I think it's here, THHN. Under 90-degree column. 55. Do you have 55 here? Oh, here. You have 50? So is 50 under 75?
Yeah.
They must have used, I bet you that's what he used. That this was THW because it's, yeah, it makes sense. Thank you. I know one Lewis is aware. So, yeah, thank you. That's why everybody understand that? Good point. Because outdoor, that would be what? 70? 75 degree. This then will be 50. Thank you. 50.
What about the minimum allowable capacity? How do they get that?
Doesn't apply to number 8. Number 8 does not apply to it.
I know, but the way you told us to figure that out, it doesn't work out for me.
Okay, just hold your horses. Now, let's go back, guys. Finding this number. Any question about finding this number? Taking it to the table and finding number 8. Any question about that? Okay, now the problem is this. Do you guys have the same derating factor, 0.88? That's my problem. After you size your conductor number 8, you're going to go, how much current number 8 can carry? 50. But I only need to carry what? 46.7, but it can carry 50. So you take the 50, because there's high temperature, take the 50 and multiply it by 0.88. Tell me what's going on. 44. 44 amp. Now, is the 44 amp, it doesn't.
That's 45 for overcurrent protection.
Yeah. 45 for overcurrent protection device, guys. this is 45 for the conductor. No, the overconduction device is 60 here. Is yours 60? 45? Yeah. This is from the manufacturer. This guy's manufacturer. But then you multiply, then you compare the two. What's so 44 and 46. Then you have to go, and he stayed with size number 8, didn't he? Interesting. Unless you use this wouldn't cut it based on the temperature. It would not cut it. We see that number here should be larger than this. These two numbers, after you derate it, you should come up with a number more than this, or you have to go to number 6 now. Did you guys have number 6? No, it doesn't have number 6. Number 8. That should not cut it. That wouldn't cut it. What was the, but that's, can you get, is this verified as a temperature?
It has a note with it.
Yeah,
Note number 5.
okay.
The minimum grade circuit selection current includes any required 105% factor.
It includes, yes.
Yeah.
It's already included. Yeah. Okay, so basically, guys, that's the process that you go through. You do this, and at the end, you find the amps multiplied by this factor. This number should be more than this number, which is not. So I assume I'll contact the publisher. This number should be, I don't know if I'm missing something, but that's the process that you go through. Yes, sir.
Is it pretty sure it's 240 volts?
It has to be.
It has to.
Because it wouldn't make any sense other than AC, typically single family. If you look at the schedule, they're using 24120 for this project, so it has to be 240. Is it 28? Oops. And 3-phase? Is it 3-phase? That's our problem. Sorry, I'm still in the residential. Okay, let's do it one more time, please. Let's do that one with, now this makes sense. 208 times 1.73. Give me the amps. But where did he get his amps here then? 11,196 divided by 28 times 1.73. 31.1. Do I have a second?
Yeah.
So how the heck did he come up with 35.3? Okay, let's do that. 31 point what? 31.1 M. Okay. They multiply by 125%. Includes, or you have to multiply it. So if you multiply this by 100, 1.25 over 2. On them. The load multi-M includes 125, not number 5. The load VA includes, so the VA is already including the 1.25. The VA though, that one, right? This number is already included 125%. Guys, without getting into the details, can I get you to understand two things, please? The first thing is when you find the amps, you're going to go to the table, find the conductor, right? That's easy. Doesn't matter what voltage, what amps. You find the amps, you go to 75 or 60, depending on the logs, and they have to tell you that. They have to tell you. Is it 75? And you go find a conductor. Can I have thumbs up by doing that? That's easy. Doesn't matter what he did. Then, after you find the conductor, then, can I emphasize the word then, you take your conductor, and under whichever column the conductor is rated for, like his THW, find how much maximum current that this conductor can carry, right? In our case, 50. Then you multiply it by the temperature and derating factor, okay? And that will come up with 44. Then make sure this, if this is the case, it's right, guys. If it's 31.1, then your answer will be 44 amp, which is more than what you need. After you derate, the conductor still have more juice in it. Look, it was 50. After you derate it, if that's what the answer you guys gave me, we still more juice than when you need to, then we're good. Now what happened if the situation was like we did before? You go to next standard up. What's the next standard up from 8? 6. That's it. Really, that's the whole derating. This. Yep. Yep. If any. Yep. Absolutely. If any. If any. You know what? Can I do one little example for you guys in 5 minutes? Can I? Do you have juice in your left? Just one example, and we do it together to get you, because I don't like the way he did it. Let's do one example, one quick example.
Yeah.
One quick example for that particular one. Very quick.
Yes. I like that.
Math is your favorite. Okay, here. Do me a favor. Do me a favor. Here's the load. Guys, here's the load. The load is, let's just say it's 50 amps. Continuous. Oops, 50 amp continuous. 50 amp continuous. And I need the size, okay, 50 amp continuous.
Yep.
The conductors that I'm using is T, H, H, N. Okay? Everybody's okay with this? That's my conductor. And the ambient temperature equal 130 degrees Fahrenheit. Cool? Everybody's okay with that? Yeah, 130 degrees Fahrenheit. And because I'm also dumber than a rock, I decided to group another circuit with it. I have in the same pipe, there's a pipe that's going like this, guys. Here's my pipe. In the same pipe, just imagine there are 8 carrying conductors in the same pipe. Now, how dumb that would be, but okay, 8 of them. I have thumbs up, Chad, and let's go size the conductor and the overcaptation device from the get-go. You guys will know how easy that is. I think it's complicated, huh? Okay, conductors. Is it continuous mode, gentlemen? 1.25 times what? 50. Give me the answer right away.
62.5.
Second. 62.5 amps. Any second? Okay. Now, I'm going to tell you guys the lugs. I'm going to tell you about the lugs here. So I had to tell you the lugs are rated for 75 degree Kelvin. The lugs are 75. The lugs are what?
75.
Okay, good. All right, then take the 62.5 amps. Which table and why? Table B10.15, B16, under which column and why? Why? You just told us, Chad, right? If you don't know, when would you go based on the amps? Based on the amps? 60. Okay. You would have told us that, right? Okay. What was that? What the conductor? Let's say 3 conductors, 3 phase. 3 conductors, number 6. A, W, G, T, H, H, N. Done. Let's size the overcaptation device as long as we're on it. Overcurrent protection device, which is basically the circuit breaker. Guys, the same calculation. You take 1.25 times 50, get you 62.5 amps. You take the 62.5 amps. Jerry, where do you take it? 240.6, and that will get you, next standard is what? Do we have 65 or no? 70, thank you. 70 amp circuit breaker. Here's my size. Now, this one, 75 degrees Celsius. The C is,
Did you just mean the C dot B or the C?
Yeah,
The C dot B is
yeah. My C's are laying low here. Okay. Any comments so far? Any comments, guys, about this? Nothing. Now, if you don't have derating and temperature, you're done. If you don't have derating and temperature, what are you? Done. But I have a problem. I have a temperature and a derating. Okay, so now let's go check if that sucker will cut it or not. Okay, so now let's start with number 6. Number 6. AWG THHN. Take it to for derating. Derating. Table 310.15 B16. Which column? 90 degree. Why did I go to 90 degree? We're derating. If I wasn't derating, would I go to 90 degree? Never. What's the amp for this guy under this table? 75 amp. That's a far cry from the amps under 70, right? 75. 75. Okay. Take your 75. 75. Okay. Do me a favor. Let's cut it. I'm going to cut it. Based on temperature. Take this temp. I'm going to do it this way. Here, where am I going to do it? Right here. Okay. For temperature, 130. Take it to that table, the temperature table. Give me that factor. How much? 0.76. For 8 conductors, carrying conductors. Take it to the table for the current. Give me the factor. How much? 0.7. I need everybody to verify this.
Where are you getting that from?
Okay. Degree Fahrenheit. The first one is coming from table 310.15 B2A. 310.15 B2A. Everybody verify it under 90 degree column. Please do. For 130 degree, under 90 degree, everybody verify that this is 0.76, right? Everybody got it? Next, the next table. What's the second table? I don't have my code. 310.15 B3A. B3A, can you verify 8 of them can give you 0.7? Okay, got these numbers. Now, look what you do with them now. What you do with them is you multiply them right here. 0.76, multiplied again by 0.7. What do you get? Do you have a calculator handy? So just multiply them by 39.9 amps. 39.9 amps. Any second? Okay. Now, what did you guys come up with? 36? You multiply it twice. Now, divide, multiply.
Is that 0.76 or 0.7?
This is 0.76.7. That was probably 3.9. Okay, now, I would like you guys to look at the following. This number and this number. You need 62.5 amps, and guess what the conductor, because of the stupid circumstances that we have in. Am I screwed up? Big time. Big time.
How'd you get that down?
Big time. So what would you do? Here's the situation. What would you do? Up. And we do the calculation again. If it doesn't work, what would you do? Up again. Do the calculation. Keep upping the conductor size until what? Until this number here equal or larger than this number. Okay? Yes. Yes. The derated number have to be larger. This number have to be larger or equal to the number that you started with. Otherwise, you need 62.5 amp conductor, and the conductor, because of the circumstances, is 39.9. Which one? This is larger or equal in some type of a form of a language. Larger or equal. Huh?
Just taking them parallel to 68.
You can't parallel more than 1/0. 1/0 is the minimum you can parallel. You can't, right? Everybody understand? No parallel. You can't parallel a conductor less than 1/0. That's the rule. Yeah. Except there's exception, of course, for every rule. The exception is low voltage.
Why is that?
Because, you know, if you start paralleling smaller conductor, paralleling is inherently dangerous because of the length and the requirement and what's not. You start paralleling smaller conductor, you expose yourself to more danger than you need to. The reason why we parallel, guys, because the conductor becomes big. 1/0 is big enough. I mean, if anything less than 1/0, you shouldn't parallel. Okay? Any comments, question, guys? How do you see that? This is what the procedure is. Now, the last thing, I know killed you today. I really brutally killed you. So the last thing, guys, we do, instead of keeping going up and try, up and try, up and try, we do it from the get-go. We size based on the rating. Let me show you what little trick, size based on the rating. Okay. Now, remember that stuff that we did. Give me the amps for the equipment that we had. It was 50 amps. Start with 50 amps. Where do you get the 50 amps, guys? That's the equipment before I multiply by 1.25. The load. Start with the load. That's what I'm doing, guys, is they call it sizing based on the rating from the get-go, because I know I'm not going to cut it. I'm going to go size based on the rating. Okay. Divide this. Do me a favor. Divide this by the two factors. 0.7. What was the first one? 0.76 times 0.70. And give me an amp, will you? And do the math right, will you? First, you put the number, divide, multiply the two together, because that is a lot of mistakes. I need two gentlemen to agree on this answer. 93.8.
After a minute,
Huh?
93.9.
93 point,
Basically
94.
94.
94. 94 amps.
Yeah.
Do we have three gentlemen agree on that? Good. Then, next, you take the 94 amps, you take it to the following table. Table 3, 10, dot 15, 3, 16. Under which column and why? Are we derating? Yes. It's the conductor is T, H, H, N. So we have to go to 90 degree. Why are we sizing based on the rating, Chad, but based on 90? Because we're derating. Okay, give me a conductor. Conductor size is 3 conductors. Number 4. AWG, thank you. AWG, T, H, H, N. Now do me a favor, go back one step and compare it with the number 6 and choose the largest. One more time. Remember we start with number 6, right? No. Absolutely. Absolutely. See how easier that is? All this junk here, first size, we still not say overcomputation, size this step. So if you guys want to summarize, first do this step here for the conductor, then jump directly to the next step right here. The next step, based on the rating, there's your conductor, 90 degree column, number 4, and you pick the largest of the two. You could be in a situation where one of them will be larger. You pick the largest of the two. Always. The circuit breaker is still, you still have to do the same thing with circuit breaker. Except now instead of having number 6 landing on it, you have number 4. Okay?
Why don't we just like that?
Why three? Because I'm telling you three phase. Yeah, it could be two, could be, yeah. The three, this number three guys here, really, it depends on what system you have.
And single phase would be
Will be, okay, single phase 120 will be two, single phase 240 will be two. Depending on three phase will be three. This number really, they have to tell you. Now, do me a favor. Can I just take you guys one step? Now,
The only thing we have to still do is the circuit breaker.
yes, yes. You see how easy that is?
You're like, oh,
Who'd say?
show the very
Who'd
long
say
way,
easy?
very kind of easy.
Well, really, all what you have to do is just the two steps. Here's one step number, here's step two. Number two, when you size, if you have the rate, only if you have the rating. And this is your step number one. And since you're, but look at this. Huh?
At 130 degrees.
When you know it's 8 and 130 degree, you're guaranteed.
You already know you're gonna.
Yep. That's going to be the rating. So you go to step number two. But guys, I always tell the people, always do the two steps and choose the largest.
so a circuit breaker is still be set.
Still, yeah, your circuit will look something like this. The circuit breaker, was it 70? Yeah, will be 70 degree amp, and your equipment is 50, and your conductor here will be number 4. Done. Whew.
I was confused there.
That load is safe and sound.
See, that's all right. We'll do a few of these later on, guys, too. Not today, though. Let's take a break, and we'll do a little bit of CAD in a few. Whew. We're gonna finish CAD today before we switch to Revit. One more thing left in CAD, guys. Let me just finish it if you don't mind. Huh? You have- Oh yeah. Do you have anything? Question for me? Getting some stuff.
We haven't done anything as far as actual calculation.
Finish